With that being said, I'm going to welcome everyone who's joined our session today. My name is Tony Grote. I'm IPAF North America Regional Manager. And this is one of a series of educational webinars presented by the IPAF North American Regional Council. Today's focus is on the proper selection of MEWPs. This may seem like an easy task and something that you'd be questioning how can we spend an hour talking about this. But if it's not conducted properly, it can lead to some very unwarranted consequences that should be avoided. Today, we're fortunate to have with us Mr. David Webb Jr., who will be delivering today's presentation. David works in his family-owned business and operated a full service equipment company, Well Built Equipment. Well Built prides themselves on their extensive commitment to detail and safety. Dave's worked in the business his entire life and is recognized as an access equipment expert. As a dealer and provider of aerial work platforms, assisting users is a critical support function required to be productive and safe when undertaking all work at height. Today, we're pleased that David has volunteered to share his knowledge and experience as a mute dealer on this topic. And knowing that there are various types of mute categories and models within each category, and mutes have various rated capacities, work at height and reaches, and the user must select an appropriate machine based on consideration of many factors, including but not limited to the task to be undertaken, the constraints of the job site, ground conditions, site access, and proximity to the public and other workers. David will explore with you how to assess worksite conditions, task requirements, equipment specifications to make an informed decision on a suitable mute. So with no further ado, David, over to you.
Thanks, Tony. Before we get started here, if I go to my next slide, just want to remind everybody, if you aren't already aware, this fall, October 15th, 16th, and Nashville is the Working at Height Conference and Awards. It's always a good time to go to the IPAF conventions. So if you guys do have some time in your busy schedules to come to that, be great to see some of your smiling faces in person again and talk shop about aerial lifts. So be sure to hop on the website, find out the details, get your hotels early, all that stuff. So today we're going to go through proper MOOP selection. This is a presentation that we do for a lot of our customers, end users, other rental companies, different people throughout the industry that we normally call the ABCs of aerial lifts. And basically, the idea here is to give an overview of everybody's roles, what they play in selecting your equipment. So before we get too far, a little bit of introduction about myself. So an access equipment expert's my title. In short, it's a made-up title for a guy who's a little obsessed with access equipment. The other guys at our company who are salesmen are access specialists. I have an unhealthy obsession, as my coworkers and family would say, with aerial lifts. So they gave me the title of expert. I've been working at Well Built and International Equipment for over 25 years. We do everything from powered access equipment like lifts, material handling, forklifts, telehandlers, scaffolding, swing stages, sidewalk canopies, debris chutes, pretty much anything for work at height we provide, with the exception of cranes and rope access. I have over 18 years working as a mechanic, doing sales, installations, and more. A couple different certifications for training, including from IPAF. And then a little bit about our company. We're weird in the rental company market. Most of our business is actually service and sales. We do have a large rental fleet, but we do everything from small repairs to full down tear downs of equipment. And then my fun side hobbies that I have is we work with equipment manufacturers on manufacturing, assembly, and design to improve the overall industry. So a little bit of an outline here about what we're going to go through. I'm going to do a little bit of the who, what, and where. So who are the key players in our industry? Our factors in determining what MEWP we use, how to choose the right equipment, and then, of course, we always leave room for questions because that is our favorite part. So let's go ahead and dive in. Here on the side, this is one of our machines. We took frame all the way down to the frame to do a recon on for a customer. And that's kind of the way we look at lift choices is they have to be from the frame up. So right out of the gate, I want to share this old photo for some of our older industry guys. You may be familiar with the old Simon MP series. This is back when the constructor booms were kind of in their heyday in the 90s. You can see not much safety devices, not many features on this machine. So the question we have always on MOOP selection is, are we an industry divided or one that's united? And this comes from a couple of places, and here's why. We all have to work together to understand the roles each of us has. We need to know how the decisions we make affect us all. And the end goal is to increase powered access equipment use. So together we can change the industry and change the game. That's our motto, always at work. And the idea behind that is we want to eliminate ladders on job sites. The ladders last initiative for us is something we really, really take pride in. So a little bit about the who, what, and where. This here is Dave Sr. He's the guy that has taught me most of what I know besides my uncles. And what this does is it establishes what everyone's responsibilities are, kind of gives everybody an idea of their overall position in the industry, helps us avoid to blame each other when problems do arise, and understand that we all have to work as a team because we're all seeing the same problems, whether that's from a manufacturer or standards organizations, all the way down to an end user. There are common pain points that we're all having right now. So here we go. This is our who is involved in the MOOP selection process. So starting with our standards boards and organizations, that's where the industry guidelines for manufacturing of equipment training certification start. Into a manufacturer who designs, engineers, manufactures, sells, and provides support. Then we have a couple of different type of equipment owners. We really, in our industry, separate a small rental company who focuses on general rental from a larger rental company who has access-specific operations. And then also the equipment owners who are an end user or COM, we call them. Those would be people who decide to purchase a MOOP for their own company use or location. We have our trainers and safety organizations such as IPAF, the users who direct someone to operate a piece of equipment, and the operators. And for those of you who have done the IPAF training or one of the other certifications, you're going to be very familiar with some of these terms. If you haven't, I would suggest you do one of the training sessions. They're very informative on understanding everybody's roles in the industry. So we're going to get into then the what of the equipment. So this is how we break down our four most common types of MOOPs. In this case, we're talking about things that are not truck-mounted units and not mast climbers. And the reason why is for the most part in the general rental and equipment environment, that's kind of two separate categories. The truck-mounted guys almost have an easier time choosing a machine because they all have similar operating characteristics. It's just more about height and reach versus all these other type of MOOPs that we focus on in our training are more specialized in where they can and can't be used and the different types of things that they do and perform. So we break those down as scissor lifts, boom lifts, outriggered machines, and then push arounds, or as we like to call them, the new guy lift, because it's really fun to put the new guy up in a push around. Then we have the where of how the MOOP selection occurs. So on the side of people who aren't directly involved with end users, we consider that an office decision. That's your standards such as ANSI, CE, OSHA, organizations, engineers, and manufacturers. I see I have a nice generic photo of a guy with some blueprints here. We have an equipment rental yard or a retail yard where someone's selling the equipment. And then, of course, we have at work sites where hopefully, if you choose the right thing, you don't end up burying it down to the counterweight. So now we're going to get into our factors that we consider in MOOP selection. So you can see right here, we have somebody who made the unfortunate choice of driving too close to the form work and sunk a wheel on this machine. Here we kind of go into the details. So what this is, so everybody knows, a lot of our presentation is going to be from a larger rental company standpoint. And then we also work with small rental companies as well. So I know everyone's factors are going to differ. The idea here is to show how we view those common points and how we can unite behind them to make the industry as a whole better. So at the top of it, we have the price or cost. And that doesn't just include the initial purchase price, that also includes how we maintain it and the longevity of that product. Transportation and storage. How does it get to the work site where it's going to be used and where is it stored? So in an end user situation, it might have a different storage location than a rental yard or retail. Availability of equipment. Is the ideal machine that we want to use available to use? Can we substitute it? And then we get into the height, reach, worksite conditions, and ultimately end user preference. The end user preference thing has become more and more of, I wouldn't say an issue, but a solution where the end user becomes very familiar with a brand. And because of that, they're used to its operating characteristics and don't want to change. So we're going to dive into the details of each of these here next then. So the main factor we're all united on, of course, is the dollar. And it's very important to everyone. The bottom line ultimately is determining a lot of business decisions. And that's why I always start at this point is it seems like the dollar and the cost of something is unfortunately the ultimate deciding factor for anyone. And we'll kind of tie that all in and circle it all back. So a little representation when we sell equipment, we have this thing that occurs of the this is what someone can afford and what they actually want is a brand new machine. Uh, that big gap that we have is a lot of what causes the selection process to go away from its focus and towards a monetary decision rather than an informed product specification decision. So what I do here now is we're going to break down how each of these things affects, from our point of view as a rental company, the big key players in our industry. So how does price affect our selection of equipment? From the way that we see it as a rental company, a retail service sales company, safety training company, this is our perspective. Again, yours might differ a little bit, but this is kind of how we view the whole process. On a standards board, standards must meet minimum requirements, and they can't be too costly to implement and design, and they can't be costly to adhere to after the delivery. From a manufacturer's standpoint, they need to meet standards without adding extra cost. Raw materials and bolt-on costs ultimately determine product features, and then the price must be competitive in the market, especially with so many new companies entering it right now. On the rental company side, everything comes down to that low cost of ownership and low acquisition cost. Whether we want to admit it or not, ultimately, lower rental prices open up more opportunities for us as a rental company. It's not necessarily the product selection. It always comes down to whether or not the customer can truly afford to get that piece of equipment. On the safety and training side, the training has to be affordable. So part of that is if training takes too long, customers are less likely to do the training because it costs them to have their guys in a training session. Required safety equipment has to be affordable, and price determines the market acceptance of our safety equipment and training. And then we have our users and operators. Price determines ultimately if a product can be used. If they don't have the money in the job or repair, they can't do it. And they often substitute cheaper products for the ideal product because of that. So this is what I call the results side of what has happened to higher prices without added features. In other industries throughout the years, what we have seen in equipment is we have seen an increase in features that have ultimately gained something for the operator. For example, right now, if you want to go buy a skid steer, you're going to get an enclosed cab with air conditioning, heat, backup camera, extra safety devices, maybe a Bluetooth radio, high flow, higher capacity. All of those things that are added ultimately justified an increase in cost. Whereas in the area lift industry, we have seen large increases in costs throughout the industry from the manufacturer all the way through an end user without getting a lot of huge advantages to that. So, on the standards side, when standards become too costly to implement or take too many resources, we lose innovation and product features. As an example, load cells on lifts did not give operators more, they actually took it away. And we know that people were overloading the machines. It's commonly known, but right now we have an issue that customers will only take older machines because they know they can overload it versus a new one. On the manufacturer side, when price is the sole focus, a brand no longer becomes a selling point on features, but instead becomes a commodity with no product separation. The focus on selling at the lowest price without giving us the better product has really caused an issue where all we have is a bunch of the same product with different paint schemes, really, and some different bolt-ons. On the rental company side, we too, when we focused on price, lost our trust of our customer base. By changing brands constantly, a customer doesn't get consistent equipment, they don't get consistent performance and specifications, and they ultimately have trouble deciding to stay with that brand. And what that has resulted in for us is a direct sales to end users have fallen off. And customers really are focusing on price rather than the equipment, which we could help change and are doing our part to do so now by focusing on having 1 to 2 brands. On the safety and training side, proper training and certification to keep up with changing standards increases costs beyond a point where training is continued. So, as an example for this, in the last 3 years, we've seen over a 90% fall off in people signing up for training classes at our shop. They basically only sign up to do training when someone has come to the site and asked them for their card that allows them to operate that piece of equipment. And that has to do with how long the training time is, what's involved in the training, and the ability to even do the training on the site, such as setting up a course for someone to show their operator efficiency. On the users and operators side, lower cost outweighs proper MEWP selection, and ultimately an office person makes the decision for the operator. If they don't have the money in the job, they're just not buying the piece of equipment or not renting the piece of equipment. So then we have transportation and delivery of the MOOP. And again, this is our stuff that we have. If you go state by state in the United States, if you travel to Europe or you're in Canada, somewhere else in the world, obviously the road limitations are completely different than what we have here. For example, the commercial driver's license limit in Europe being 3.5 metric tons versus here it's much larger. So when we're trying to decide what MOOP a customer can ultimately use, we have the weight to consider. So what are the vehicle requirements that they need to get it there? If we stay under 6,000 pounds with a trailer, there's no need for electric brakes. That's a much larger customer base who can then tow it. If we go under 10,000 pounds, including the trailer, they stay under a commercial driver's license. That trailer does now have electric brakes, but we still are under that limitation where they need to go through the process to get a CDL. On most of the rollback trucks, unless you get a high capacity one, you're maxing out at around 26,000 pounds. They may hold more, but they'll never scale, especially with a boom lift on there and all the counterweight forward. And then we go up to our tractor trailers where they're under 48,000 pounds for our whole load without having to pull a permit. And again, we have axle limitations as well. So if we're overweight on an axle on a larger boom, we have to pull a permit for that depending on where we're going. A good example of this would be booms above 125 feet typically are too heavy for us to carry without a permit, depending on where they're being delivered. And that added cost prevents someone from getting the machine ultimately. On the length and width side, We have different vehicle trailer requirements depending on how that machine is made. For example, in the lightweight lift categories, you have spider lifts on tracks. Those always fit between the wheel wells. When you move up to something like a nifty SD64 with wheels, it may be the more ideal machine, but it becomes too wide for the more common trailers, or it rubs when it gets loaded. And with that, of course, the common things: how long and wide is the trailer or vehicle? And do we go to over length or over width items, or do we need a specialty trailer in order to transport it? The most common one for that over length, over width issue is when you go up to a rotating telehandler and it's just too tall to put on our standard delivery trucks. Then the last thing we're looking at is where are we going to actually deliver it to? So this is a common thing on our quote sheets we go through. Is it a ground or dock delivery? What size truck can fit into that actually location? A lot of that has to do with road limitations to get there. So we may have to stop at the entrance to an area and then drive a piece of equipment in. That means if they need an electric scissor lift in an open warehouse, we may have to send a rough terrain scissor lift there because we have to deliver it further away. Is there material handling equipment available to assist? So this would be on job sites or areas where the ground is tore up. Can we use a telehandler to get that machine into the building rather than having to get our truck up against it? And then, of course, the type of building. So residential areas, we try to stick to a truck and trailer. Commercial warehouse areas, usually we can use a larger truck, but we're always confirming with the customer if our large truck can fit there or if we need to send a small truck. And that can determine what type of equipment we can actually physically get to the concrete, as we call it, or on the slab. So now we're going to go back again here. How is transportation and delivery affecting our selection of that MEWP? So a manufacturer designs and manufactures a machine based on the target customer base. If a machine meets the specs but cannot be delivered or requires additional cost to deliver it, it negatively affects sales. So a good example of this is in the chimney industry. For instance, our customers need a large articulating boom, such as a Z80 from Genie or a 860 AJ from JLG. That machine allows them to reach up and over the rooftop, but we can't always get it there. So we're substituting a spider lift for those cases because they're lightweight and they won't damage the property. If you're a smaller rental company, you may focus solely on customer transportation rather than delivery, meaning you're taking into account what vehicle they're always going to pull your trailer with or their trailer. Customer ability to transport may become this priority then in your decision making for what you give them. You might not have CDL drivers and you may not have larger trucks. Then we get up to our medium to large rental companies. In our case, what we're looking at with equipment is, are we going to need to purchase more trucks or trailers to keep up with delivery demand? Is a large enough truck available for that day to do the delivery, or are they booked out? And then can that truck, since we're going to a larger truck, fit into the delivery location like we were talking about? Ultimately, we have a lot of the same limitations of a smaller general rental company because we also have customers picking up equipment and we're also delivering to the areas where a customer would normally bring their own equipment. On the safety and training side, transportation really comes down to whether or not it's going to go safely. So, can the equipment be transported safely is a huge selection choice for an end user, such as if their vehicle can handle it, what's the situation with their trailers, are there excessive training requirements for transporting? So in that case, it would be something like a folding jib or a rotating jib or a particular sequence of buttons you need to do in order to load it onto a trailer and not damage or disable the piece of equipment. And then does it take too long to properly secure the equipment? So that one on the safety side for loop selection is a key component that we see with a lot of people who buy equipment. Very commonly, they take what we call the safety shortcut, and something that should have 4 or 6 tie down points ultimately ends up with 1 or 2, and they just cram it against the bulkhead or hold it down with a winch in order to decrease the amount of time it takes to secure the piece of equipment. On the owners, users, and operators side, that transportation is very, very key. For instance, a garage door company, can I transport the MOOP on my own? If there's someone who has a crane on the back of their service truck as a garage door company, they may choose to stop at a 20-foot machine because that's the limitation of their crane mounted, while other companies are using maybe a roll off deck or a larger truck and they can carry up to a 26 or 32 footer. They then look at, can I afford the additional freight costs, or can those freight costs be passed on to the customer? So we'll use the same example of a garage door company. If they're going into a repair and their customer is not willing to pay the additional costs of that MOOP, then they're going to use ladders. And then their last thing is, can I substitute a MOOP that may cost more but is easier to transport? This is becoming more and more common where we see customers purchasing a more expensive piece of equipment that may be more complicated, such as a spider lift or a lightweight wheeled machine, in place of a traditional boom so that they can transport it themselves. And that brings up a whole litany of other safety concerns because they may end up using the machine in an unintended purpose. Then we have availability. So availability for us is huge. As we say at our company, one is none, two is some. So buy a truckload, which a manufacturer I'm sure loves to hear. So again, this is from our point of view, how we view the availability side. In the manufacturer side, is there a need to make additional models? Do those additional models compete with existing models? And can we get a more diverse product line to our customers without increased overhead? Obviously, we all know and are aware as owners and operators of equipment that that design cost and the upfitting to do manufacturing on an industrial scale is extremely expensive and cost prohibitive. And that's a hard decision that many companies struggle with to see if the market viability is there before they start to make it available. In the small rental company side, what we see is they have a limited MOOP fleet. They may only have one MOOP in a product category, and they're often substituting a different machine. The primary reason for that is they either do not have the capital to invest in a diverse product line or they don't need to. So, a good example of a small rental company is they may have one push around lift, which could be like an AWP 30 from Genie, as compared to having an AWP 20 and an AWP 30. They have the one. They may only get a 26-foot narrow electric scissor lift instead of the more common 19-foot scissor lift because they only want to own one of that unit. And the same thing transfers to rough terrain scissor lifts and to boom lifts and to tow behinds. Then when you get to a larger rental company, in our case, we carry a more diverse fleet to serve specific needs. So we have 72 different models of lifts we carry at Wellbuilt. To give you an idea, it's quite ridiculous in our opinion that that's what we need, but ultimately it's become the best thing for the customers. And we carry additional overhead to meet specific needs, which lowers our profit. That ultimately prevents us from buying the available equipment that a manufacturer is making, is because we need to carry this specialty stuff to truly get a customer the exact machine they need. And then we often substitute a different machine based solely on cost. In our case, a great example of this is we have a significant amount of customers who call and are looking for a spider lift or track lift. And it turns out when we go look at the job site that we can just substitute a larger machine. So they may think they need to get right next to the building, and we end up substituting a 60 or 85-foot boom that is cheaper to rent and easier to operate and ultimately has less safety concerns with it because of that and the additional training requirements and saves the customer money at the same time. On the safety and training side, can the available equipment be used safely? Is the available equipment beyond the operating capacity of the individual? For those of you who've done safety training classes, if you've ever had the joy of doing them for a high school, you end up with a lot of people in there who ultimately should never use a lift, but are being trained how to use a scissor lift or a push around so that they can get balls off of the ceiling in the gymnasium. And then can we safely substitute something without creating additional hazards? So a good example of this again is if a customer was requesting a spider lift, but we're now substituting a larger machine, that larger machine is more susceptible to ground conditions such as buried water lines, power lines, sprinklers, things that are hazards we normally wouldn't have to worry about because a spider lift is not going to dig in and bury itself, whereas a larger boom that weighs 26 to 32,000 pounds or more might go through and actually damage the underground structures. And then we go back to the owners, users, and operators. In their case, availability is, do we own the exact MEWP that is the ideal one? And is our ideal one that we do own unavailable, meaning maybe they only own one of the ideal MEWP? Does my rental company that I prefer to use have the MEWP I need? And will I have job delays if I wait for the ideal MEWP? It's important to understand nowadays the chaos that occurs on a job site due to material delays, someone getting delayed on another project and then not being able to work at that particular site. What we have is a lack of advanced planning that didn't used to be there. We thought technology would fix that in construction and ultimately has created more chaos. Where, for instance, if you are the plumber on a job site, you might all of a sudden be contacted by the general contractor and say, hey, I know you were supposed to be here 2 weeks from now, but I need you here tomorrow because the sprinkler fitter or the electrician had product delays or is behind or ahead sometimes. And that determines how they would select the MOOP they deliver there. That might be that when they were scheduled to go there, originally there was going to be a very small opening, such as a man door was the only thing left. But now there's a huge opening in the side of the wall because they're there 2 weeks early and they can use a bigger piece of equipment. So availability goes into substitution. So on the manufacturer side, are we making MOOPs that are too easy to substitute for and do not serve a specific need? As an example, a micro 19 can often be used in place of a standard 19. A 32-foot scissor is often bought in place of a 26-foot scissor to increase our utilization. So this was a thing that I have tried to talk multiple times about, and it seems like maybe falls on deaf ears is that we have the same number of 19-foot machines that we did 10 years ago. It's just instead of having one version of a 19-foot machine, I now have four. And ultimately, they do serve specific purposes, but those increased costs, those lack of utilization becomes the reason why we don't fill our other gaps that we really do need to fill in a rental company operation. So then our small rental companies, if substitutions cover most needs, they will not buy a specific product. Going back to the same example we had before, where they buy a larger model to cover a broader range of rentals. They often substitute a larger machine, as I just said, and they often substitute a different move, such as an RT scissor for a boom lift. And the reason why is maybe they only own one of each. Their regular rental customer comes there. The only one that's available is an RT scissor lift, and that's the one they take and they adapt to the situation. Is that necessarily the safest option? No, but it is what happens constantly on a regular basis at a rental company. Then we go to a medium to large rental company. We use substitution to fill gaps in specialty MOOPs. That same example, we have a rather large spider lift and specialty equipment fleet compared to most, I would say. But we very commonly, even with that large specialty fleet, substitute more common objects in their place, especially larger ones. And the biggest reason why is a decrease in cost. So on the safety and training side, now we go again on the availability and then the substitution. Can that substitute be used safely? Oftentimes, the customer does not even know when they're calling us if we can substitute a bigger one. We have to go check the job site for them. And then we go into those same things again. Is the available equipment beyond the operating capacity of the individual? So, did we substitute something that's harder to use and thus becomes unsafe? And does that avoid creating additional hazards? The goal always is to increase safety, increase production, lower costs. If we don't meet those three things, then we're not doing our end users and operators a service that they need. And then on that owner, user, and operator side, they substitute what they own versus renting whenever possible, even if it's not ideal. We call this ladders and milk crates. So there is this constant rub of, hey, can you go check a job for me? We go there, we measure the job, say the ceiling is 27 feet. The customer only owns a 19-foot platform, and they say, I'll just make it work. We know that their make it work means they're working constantly above their head, which creates additional issues, or they're using the piece of equipment in a way they shouldn't be, like standing on the rails or putting height increasing objects into the platform. And the reason why is they're focusing on owning as few MEWPs as possible to cover the most needs. So our end user base primarily has a 19-foot scissor lift, a 26-foot narrow, and then they jump up to a 40-foot electric scissor lift because that's the largest 4x8 machine you can get. If they have those three machines and they're working in warehouses doing building maintenance, that's covering 90% of their needs. Then when they need a boom, they're renting a boom only when absolutely necessary, including if that means exiting the platform and climbing onto pallet racking rather than renting the proper piece of equipment. But what if all those factors mean nothing? I can choose anything I want because we have hundreds of lifts to choose from. This is the scenario that we're in most of the time. Just like farmers, you've got questions, we've got answers. So this is the choosing the right equipment part. We have all the factors that help us choose the wrong ideal candidate. Now we get to choose the right one. And hopefully it is not this old dinosaur machine that you guys see on my screen. If you guys are from the older part of the industry, you might remember these. This thing even has a Wisconsin air-cooled engine on it. So again, we're going to circle back to our four most common types: scissor lifts, boom lifts, outrigger machines, and push arounds. This is how we try to separate them. Everyone else might separate them differently, but it's our four main categories we focus on in safety training and certification. So this is our chart of how our rental division would choose the right MEWP for a customer. Equipment specs ultimately fall into two different categories: our needs and our wants. Our needs are, how high do we need to go? How far in do I need to reach? And where am I going to put the thing? So is that, how small is the door I have to drive through? Do I have to go through a gate? Is it only a dock delivery and the dock door is only 6 foot wide or something weird like that? Uh, and can I get there in those conditions? On the want side, we have capacity. And the reason why we separate capacity into the want side is almost always we can increase capacity by getting a customer an additional piece of equipment, or we substitute a material handling device. So that would mean the customer, if they're a garage door company, they really could use a scissor lift if it picked up 2,000 pounds to install a roll-up door. And ultimately, they end up getting a small scissor lift and renting a forklift to go with it. So we separate the capacity as a want because it is easier to solve a capacity issue than it is to solve a height and reach issue. If you can't get up there, it's kind of irrelevant what you're bringing with you to do the work. So this is our tools of the trade. When we go out to a job site for a customer, we're using a laser measuring tape most of the time. If you guys don't have these and you're doing job walks for your customer, or you're an end user trying to figure out what equipment you need, we really suggest the Bosch series of them. And the reason why is they have a digital level built into them as well. So you can use that to determine your slope in two directions very quickly and make sure that that machine is going to operate where you intend on setting it up. And then when we're outside, we use a golf range finder or a shooting range finder. And the reason why we use those is they have a little bit of zoom and they're really accurate, usually within 3 to 6 feet. Buy a little bit nicer one. It's maybe $100 more. Don't cheap out on the golf range finder. By far, it is worth the $100 to $200 more to not have to send a customer a different lift and piss them off because you bought a cheap rangefinder instead of a more expensive one. We really like the Bushnell ones. They seem to work the best, but it's kind of a dealer's choice on what you really like to use there. So now I'm going to give you an example of how we measure something. So in this example, what we have is a house that was being worked on by a painting contractor and a chimney contractor at the same time. And this is the overhead view of that location. So here you can see we used one of our Polizani spider lifts. Behind here, what you'll notice is that there is very obviously a driveway. In this case, we couldn't get a larger piece of equipment to this residence. There's a weight restricted road with multiple bridges. There was no other way to get to this safely. Now, a normal person might say, I get the roof pitch is a little steep, but you could still walk it. You could set up a scaffold. In this case, these are brand new architectural shingles. They have very intricate designs on them. You 100% cannot walk this roof. If you do, you void the warranty. So we are trying to help our painting contractor and the chimney guy reach up here. So what we do, because you can't get a clear line of sight right over the top of this, is we go to the end of the structure. We're going to measure in and then measure up from the end wherever we do have the clear line of sight. And that's going to help us determine what piece of equipment will reach it. And again, you can see there's a driveway here. We easily could have just given him an 85-foot boom and he would have reached this no problem. So when we do a worksite inspection, this is the same type of worksite inspection that an operator is doing. We identify the hazards and notate them. We measure the depth or reach needed. We measure the height needed. We examine the ground conditions. We physically walk the entire area the piece of equipment is going to be delivered. We do what's called a heel check, which is if I jam my work boot backwards into the ground, it's probably too soft to drive something heavy if it goes in. And that's determining the ability to deliver their location, ground dock, etc. We always consult the specification pages of our units. In our case, we have a flip book of every reach chart of every machine that's in our rental fleet down to the serial number, and we suggest the best options to the customer, the user or the operator. So the guy in the office who cares about price and the guy who's actually going to be doing the work. And this is just like the operator performs. So this is the specifications and reach chart page for this Polizani unit that we had out there. So you can see here's our reach chart. It gives us our outrigger footprint. And of course, on this one, we really need to take into account where those outriggers land. We call that our net side reach. So everybody has a side reach, let's call it, in their spec sheet. We really care about where you can actually reach when up against the edge of a structure. So again, we go back out here, you can see the customer had flower beds and landscaping they didn't want us in. Measured from there, did we reach where we need to go? And the important thing here is not all spec sheets are the same. We say this time and time again because there's an incredible amount of dishonesty that goes on in a manufacturer's spreadsheet. And if you have taken the time to go through the details of the spec sheets that we have with customers, or you have tested them and measured them, you know exactly what I'm talking about. Or worse yet, you've delivered a piece of equipment that should reach according to the reach chart where you measured to in great detail, but it doesn't even come close. So we always confirm this with a function test. What that means is if we're using a piece of equipment and we're unsure, we have all of our rental fleet that we have tested it and measured it to confirm the reach chart is accurate. And any reach chart that isn't accurate, we have updated so we know the specific places that it reaches. Most brands are generic in their reach charts. The dimensions can be inaccurate. They apparently sometimes include a person with 4-foot long arms. Do not go by the model designation on the side of the machine. This is an important one that we hammer home with all of our customers. As an example of this, a 26-foot machine could only be 25 foot 6 tall. Manufacturers do allow for tolerances in their spec sheets. It states that on every reach chart with a plus minus of what the range is, and the spec sheets can vary in the same year, make, model based on how those sensors are set up. In position function tests are important for these reasons. Again, if you guys have done the IPAF certification or training, one of the key components is to make sure the lift actually is going to perform in the location you set it up. As an example of this, your moment limiting devices on every machine ultimately determine where it will go to and how it will operate and if it will have that reach. Where you go to set the machine up, if you have a tolerance for a slope of only half a degree to get full performance in the machine you're using, but it turns out where it's set up is a degree and a half, you're going to lose performance in that machine based on where it is set up at. So we call this in the boom lift world a work area representation versus a reach chart. On the left, we have an example of what we would consider a representation. The manufacturer is giving us specific limitations where they know at a very, very specific point they can maximize that marketing side reach and what the loads are, and at a very specific height what they are. In this case, it's important to note that it shows the machine raised entirely up on the outriggers, not with the tracks on the ground. So what that means is if you're on a slope or one of your outriggers is dropping over a retaining wall, you may have just lost 4 feet of reach on this particular unit. And then on the right-hand side, we have a very detailed reach chart where it's showing with a specific grid what the reach of this machine is at a particular height and at a particular side reach. And again, it's important to note here that while they do have a disclaimer visually in here, the side reach that's given in a spec sheet is usually with a person reaching over the side of the basket rotated at a 45-degree angle, and the guy standing in the corner to work. So what that means is here you can see this little guy is reaching over the edge of the platform, and the basket appears to be a little bit rotated compared to being straight on. In the case of this photo, the basket is sideways and they're giving an open area. So the spec sheet for this machine shows that it has 39 foot of side reach. It actually, if you follow the line down to the edge of the basket, is more like 35. So now we're going to get into all the different types of equipment. And you guys will be very familiar with these if you're from the industry. So we'll kind of quickly breeze through them. We have some of the cool new things that we have in here. We're usually pretty early adopters because we work in a lot of very old buildings, old warehouses, old industrial manufacturing facilities, and need a large amount of specialty equipment to accommodate our customers. So in a Type 3A, we have electric scissor lifts. Then we go up to an electric mast lift. If you're unfamiliar with these, the most common application we have for these is someone reaching over a mezzanine, over a window, trying to get up next to an air conditioner unit or an air compressor where they can physically stick the base of the machine underneath the structure and then reach over the top. In our case, we keep these electric mast lifts from Genie with 3 different basket configurations to suit our customers. You see here with no deck extension, that allows for maximum workspace. We have it with a deck extension, and then we also have a ceiling tile basket for this machine. So in this case, we purchased the extra platforms to have one machine that we can use for 3 different very specific instances for our customers. That increases your safety. That helps them get the exact MEWP they need without increasing costs to some other weird specialty piece of equipment. Then we have rough terrain scissor lifts. Here we show 2 different sizes of them. You have your big decks, and then you have your compacts. And there are some subcompacts, we would call them, but due to performance issues and rough terrain, we really don't like to send those to customers unless they're basically on a slab. So in our case, we always get our large deck rough terrain scissors with dual decks on them. That's for our pipe fitter contractors. They need 20 to 24 foot of deck space. And then also all of our carpentry, roof truss, pole barn guys, same thing. They want to be able to set up a workstation up there with full length boards and still have room to move around them safely. Then we have RT scissor lifts, but cooler. Uh, so this is the MEWP speed level series of machines. A couple different companies make a machine like this. The MEWP from our testing on our test track here will accommodate up to a 15-degree slope in both directions. The big advantage that this machine has is two things. You get lower ground contact pressure. So when you're on outriggers, the outriggers have a tendency to sink in places on those heavier machines because you have a much smaller footprint or area where the ground contact occurs. And then there's also a speed difference. We have a video on our YouTube page of this that shows how much longer it takes to set up a set of outriggers compared to using the speed level. The disadvantage of these machines is you usually lose a deck extension, and they also are a little shaky, kind of like a diving board, so they lose capacity on them. Then we have electric articulating boom lifts. We will only rent these to customers on concrete or asphalt, basically. And we really do not even like to stick them on asphalt because they will sink on hot days. So if you notice on these ones, the big thing to take into account is some of them are zero tail swing, meaning when they rotate around, the counterweight does not hang past the wheels. Some of them aren't. And then the ground clearance, especially on the 30-foot machines, is incredibly low. So they basically, in their design, prohibit someone from using it on anything other than concrete. Then we have electric mast boom lifts. So this is a hybrid of that Genie GR20 we had, and then our Z30s. This one commonly comes into play where we have low floor loading capacities. We need a narrower machine, or the customer needs to reach sideways and drive parallel to a wall or something that they're working on while reaching over another object. The biggest limitation to these types of machines is they can be slower and they also have limited basket capacity. Then we have RT or rough terrain articulating boom lifts. So this is the new MEWP 40 footer. If you guys saw that at the ARA show this year, same type of thing, four-wheel drive. A big thing we caution everyone with, and this is why I have this example here, is this machine is lighter weight, but will work on less of a slope compared to its heavier counterparts. So what that means is you may have only a 3.5 to 4.5 degree slope that this machine can be safely raised on before it cuts out, compared to a heavier version, which may weigh 5 to 6,000 pounds more, but allows you to operate on a larger slope, maybe up to a 6.5 or 7 degree slope, depending on where the counterweight's sitting up or downhill. Then we have stick boom lifts. Again, here we're showing one of our new MEWP 34Js. Same reason why I show the 40 footer is why I show this 34 footer. This machine is lightweight and more compact and does serve a very good need to our customer base, but it's limited on the slope that you can operate it on. And we have a common problem where a customer does not measure the slope they're operating it on, and we end up having to swap the piece of equipment out for a larger one or for an older machine that's heavier. Then we have stick boom lifts, but cooler. So this is the Hyrax machine. It'll automatically level on a 15-degree slope and drive at full height. Alma Crawler also has a similar model to this one. These machines by far are the Ferrari of the lift industry. We really like this product as an example of what happens when you take all of those safety devices and put them into full-time use to give the operator a better experience. So what it does with using those safety devices as a way to control the machine and its moment limits, rather than just stopping or preventing function, is it allows the operator to move faster, work more efficiently, and drive a piece of equipment where they normally couldn't. Our most common person we have sold and rented this type of machine to is guys who work on roadways so that they can drive in ditches next to the road. It gets them out of the lane and out of having to close the lane and away from traffic further, so it's less risk to the operator. Then we have spider lifts or atrium lifts or compact track lifts. There's a whole bunch of names for these, so I kind of stuck them all together. These machines vary wildly in their use cases. For example, we have Polizani machines because they're lightweight and aluminum and they have less side reach, but they can drive into more sensitive areas. Then we have other machines that are heavier, have a larger footprint, and have more side reach and more capacity. Then we have tow behind lifts. These ones, again, are a transportation based need and a cost based need. We have lightweight outrigger wheeled lifts, a whole bunch of different names for these. Basically, where this is coming to play for us is customers who don't want a tracked machine because it does cause damage to the ground, and they look for a wheeled unit that can drive faster and handle uneven terrain, set up quickly, and have a lot of side reach. Nifty Lift does really, really well in this category, as does Dino Lift. The Dino lifts have more side reach but less capacity. And then, of course, we have push around lifts. Really, from our standpoint as a rental company and for our end users, while the push around lifts go back to the origins of the MEWP industry, they are I'm only going to use them when I absolutely have to type of use case. For us, the most common place that these go is churches or schools or auditoriums. We also have straddle kits for our genie machines to go up and over pews, people who need to transport and tilt them back into trucks. In this case, they're very easy for us to get upstairs into buildings, and that's the primary use case for AWPs in our fleet. So now we're going to circle back to this, kind of tying everything all together. So what we did is I changed this chart from how we want to how we want to choose the right move. So again, this is that same chart I showed you before, diagram. This is really the way that we want to choose the right move. What actually ends up happening is this is how the user or operator chooses the right move. So the needs become the cost, what is the cheapest option, and that includes what's the cheapest option to maintain and own. Availability, is it available and can it actually be delivered or used there based on ground conditions? And reliability and ease of use. What MOOP has the least items that can malfunction and is going to cause me issues on a job site? The wants fall into a totally different category. What we as safety trainers, the manufacturers, industry want is we want a customer to choose the right MOOP based on the machine specs because the machine specs make the safest, most reliable choice in our opinion. So that's our height, our reach, our capacity, our weight. Can it be used on the slope in those ground conditions? The unfortunate reality is that the customer, the end user, the operators have all fallen more to that need side of cost and availability and reliability more than the actual choices that we deem the appropriate ones to be. So that brings me to the end here. And then if you guys have any questions, I'm more than happy to stick around for a while and kind of discuss anything that we just went over, or you can always contact me later if you got to run.
So, folks, Junior, thanks for your presentation, giving us your perspective and your experience, which is a kind of a different way of looking at a lot of these individual topics. So for me, I thought it was uh, interesting to hear your perspective. So anyone who's out there, there's a Q&A box on the bottom of your screen. If you have a question, if you click on that box and type in a question, we can take that into consideration. One question I had, you've been in the industry now for, you know, 25 years. And as you mentioned, you have 72 models that are out there. Is your perspective that, from the design perspective, I remember in the early years of being in the industry, which is more than 25 years ago, we started out with a push around scissor lift, and we didn't have drivable scissor lifts. And then they mounted a single drive wheel to the front of it with a hand crank drive chain on it to steer the machine. And I said, oh, yeah, we really need to make these things mobile. And the point of that is that we've come a long way with the design and options and various types of machinery that's out there, including options, which I really didn't talk a lot about, which is all of the particular options that are also going to take one particular model and make it five different models with all these, different options that could be on them, from four-wheel drive to secondary guarding to you name the options that are out there. So from your perspective, has this made it better for operators of the equipment to have the right machine?
Quite the opposite. I think in general, always cost has been a primary driving factor for the decision making of any one of the users, operators that we're renting or selling equipment to. And options, while they're nice on really large job sites, such as a data center or maybe one of the big Turner construction projects here in the States, that's a very, very limited short-term solution. That building is built one time and maintained for years and years after that. And when it's being built, the needs are very different from when it's being maintained. The issue that kind of has arisen for us is we used to have large gaps and less needs, where our rental fleet, maybe to serve all of our customer needs up to a 65-foot platform height, we only needed 12 or 15 pieces of equipment. And now to serve those needs, because of everything changing, the dynamics of how the machines operate, we have to have a whole multitude of pieces of equipment for that. And really, part of that is we were all sold that it was a good idea. The unfortunate side effect we've seen is we own a scaffold company as well. More and more job sites are going to scaffolding again, where we had moved away from it. And the reason they're doing that is it never breaks down. It holds the weight someone needs. It is incredibly safe and incredibly reliable. Our hope would be that the industry kind of shrinks back on all of these extra features, and really focuses on, I need to get the right amount of weight to the right amount of height to the right amount of dimensions up there. Smaller platforms are great. The extra decks that a lot of people have come out with has been huge for us because that did eliminate a lot of safety items. But if it increased cost, people just don't buy it. I mean, from an end user perspective, which is the most important thing, is not how I buy the equipment, but how I sell it out of the rental fleet ultimately. That's added cost. And added cost is hard to justify on any job site right now.
So then I'll challenge a little bit the statement of the cost being the ultimate decision maker, because one of the things that I saw your dad wearing was a shirt that said, "You'll be sadder on a ladder." And obviously that's the least expensive option that's out there is a ladder. And that would, again, when you're looking at saying if that's the driver, then ladders are going to be the choice. And so what's the balance between those two?
Ultimately, my suggestion is we start focusing on the fact that cost is important with the features. You can justify the features or justify the cost if the features truly add value to the customer. A good feature for that is we have high capacity machines. High capacity machines really have increased the number of people who can use a lift that before were using a telehandler with an often very homemade basket on the end of it because they didn't want to spend the money to buy the proper basket. Uh, that's a good example of something that really has gone well for us on the equipment side. On the removing ladder side of it, though, unfortunately, we don't have a 6 foot cheap, easy to work on, very reliable scissor lift. Scissor lifts cost ten to $12,000, and convincing a large number of people who have a ladder that never breaks to switch over to a scissor lift that they have to transport, store, maintain, get inspections on, it's a hard sell. You know, we can be clever with our marketing stuff all we want, but ultimately it always comes back to the cost. They have to offset that productivity. A great example of this is folding rails. We have a customer who owns about 35 to 40 19-foot electric scissor lifts, and he did the math on switching over to new equipment that had folding rails to go through a door in actual cost terms on his job site. If each one of those scissor lifts had to fold down the rails twice a day, how long does it take? What's the production loss? And added that up over the course of the year and determined he could buy a whole nother lift for that or more. So decisions like that, where someone says, what's the big deal? You only fold the rails down once. Well, it is a big deal if you're an electrician or security camera guy because you go in and out of 20 rooms in a day. I mean, it's the two-sided thing where there's the disconnect from the end users that's occurred.
All right, David, we have extended past our allotted time, so I'm going to thank you for your contribution today and presenting this topic. Thank you very much. Thanks to all of the participants for joining our session today. This has been recorded. It will be out on our website shortly after, so that those who've missed it, have the opportunity to share it with others. And again, thank you all, and that concludes today's presentation.
Thanks, Tony. And thanks to the guys at IPAF for having me on this webinar.